Good day. This is Professor Russo. I'm providing probably two videos. This is the first video on our Chapter 5 quadratics, a way of reviewing before the test. So this first video is going to be on a quadratic that's in standard form, and the second one will be quadratic that it's in vertex form. So the standard form of a quadratic, as we can see, is right at the top, ax squared plus by equals c. And there it is right there, where the important elements that we need to identify are the a, b, and c. Because from there we can calculate just about any of the points that they want us to know. So if we were looking at this first example here, now keep in mind, we're calling it y equals, but since we're really in a function course, they may call it f of x equals ax squared plus bx plus c. Okay. So first of all, we want to identify what the a, b, and c are. So if we come here to this x squared minus 2x minus 3, there's a 1. I sometimes call it the ghost 1, that is understood, not 0, to be in front of that x squared term. So a is equal to 1, b is the coefficient in front of the x, negative 2, and c is the constant number at the back end of the equation. It's like when we're doing y equals mx plus b, it's the back number, it's like the b, and it tells me the y-intercept. And likewise, this c will help me with the y-intercept. So, first of all, you can see that at the bottom of the page, this is kind of like a summary sheet of how to graph a quadratic, what are the important elements we need in a quadratic. So, let's look at the first one. It's saying, how do I know if the U-shape parabola is what we call it, okay? How do we know if the parabola is headed up or down? And it's all based on that a value that we circled up at the top of the page. When the a is a positive number, it goes up. When a is a negative number, it goes down. So we could look right where we are. We can see, I'm going to write it here, that a is a positive 1. And therefore, we know that this parabola is headed upward. Now, you could look at the picture and say, I knew that by the picture. But if I didn't have the picture there, you want to be able to look at the equation and know it's headed upward. Okay. The axis of symmetry is a vertical line, okay, that has an equation, and that vertical line is kind of like the mirror line, okay? And it helps us visualize. The axis of symmetry is, as you can see in the picture, labeled right there, okay? I don't have an orange marker, so we'll keep it kind of like reddish. And it is dotted because it's not really part of the U. It's not part of the parabola itself, but it helps. There's only one point that's really on that axis, and that's the vertex. We'll come to that next. But the axis of symmetry is a line that separates, if you want to say, the left side of the U, which I'm highlighting now with blue marker. And if I reflected along over that mirror, this point here in blue would come over here. And this point at negative 3 would come over here. And it would allow me then to smooth out the curve on the right. So we want to know what that mirror is, that axis of symmetry. And its calculation is equal to negative a over b. So it's, let's calculate it. Let's come down to the bottom here, okay? And let's calculate that equation of x equals negative b over 2a. So let me see if I can write it over here a little larger. Okay. And so we're going to have x, and we'll use blue, x equals negative. What is the b? Well, the b up at the top, we said, was a negative 2 over 2 times a, and we said the a was 1. So what we have here is when we calculate that answer, we'll shoot it over here to the right side. First of all, I have a double negative 2 on the top of the fraction. That makes it a positive 2. And the bottom is positive 2. So the equation is 1. The equation is x equals 1. Okay? Because it's a vertical line at x equal 1. And notice, when we look at that axis of symmetry on the top picture, look at where it crosses. I'll use a green highlighter so we could see. Look where it crosses, where x equals 1. And that line passes right through there, okay? And it gives us the starting point of finding the vertex, because the vertex has the same exact x coordinate as where that line falls. So our vertex formula is negative b over 2a, but we just calculated that, comma, substitute it into the function. Take that negative b over 2a result and plug it into your function, okay? And it becomes the y coordinate. So the x coordinate is negative b over 2a, and the y coordinate turns out to be the result of substituting into negative b over 2a. Okay. So if I come to that turning point, that's number 3 down at the bottom, the vertex, the turning point, and we actually look at calculating it. Well, I'm going to bring it way down the bottom here because I don't have too much room, right? So we have negative b over 2a right here is 1. We just calculated it for the axis of symmetry. Now I have to substitute that 1 into the function. So I'm going to take my function, which is y equals x squared minus 2x minus 3, and I'm going to replace the x with the 1. Okay. And then I got to make sure I do my calculation right and don't make a silly mistake with my signs or something like that. So I come up with 1 squared is 1, minus 2 times 1 is 2, minus 3. And when I calculate that across, I come up with 1 minus 5, which is negative 4. Therefore, that point, that vertex point, we'll go red again. Okay. So that vertex point is 1, comma, negative 4. Now, we did that algebraically without looking at the picture. Now go back up and look at the picture. Can we see that red point there called the vertex? Can we see that in order to get there, I have to go 1 on the x and down 4 on the right? There's our vertex. That's a critical point, because either that vertex is a minimum of the graph, the lowest point, as we can see here, or it could be the higher point, the maximum, if the u was going in the other direction heading downward. So that's a very critical point. The nice easy point is to get, I'm skipping the x-axis for x-intercepts, the y-intercept is 0, comma c. So 0, comma, that c that we had at the top of the page is negative 3. So we can see that the intercept is 0, negative 3. Look at the picture. There it is right there. 0, comma, negative 3. Right. Now I skipped the x-intercepts because it's the 2 points where the parabola crosses the x-axis. Okay, so I'll come with yellow this time. The 2 points where the parabola crosses the x-axis are there. Now, in the homework, they asked you to use a graphing calculator, and hopefully you used Desmos that I sent out to you, which is a fast, easy way of seeing it, and to find those 2 points. But on the test, we're not going to ask you to do that, okay? And the reason being is in our next unit, Chapter 6, we want to find those 2 points using algebra. So I don't want to throw you off by worrying about it trying to use a graphing calculator to find them, because next chapter we'll know how to find them using our algebra techniques. Okay, so you won't see that on the test. But you do know, by the way, you can see where they are. I'm going to put them in yellow. -1, 0, and 3, 0. So if we put those points together, we have a pretty good picture of that blue U-shaped curve. Okay? And the only thing that we don't have is a symmetry point. Okay? A symmetry point is where I use my axis of symmetry to find another point. And I don't want to find it by doing all that work that I did there down below on the bottom of the page where I have to substitute in. So watch how easy we get an extra point. I'm always going to tell you to look for the y-intercept to get this extra point. So here's our y-intercept. We'll stay with red. Okay. You notice that it is 1 unit, 1 notch away from the mirror. So if I reflected that point on the opposite side of the mirror, which means I went 1 unit to the opposite side of the mirror, here's that new point that I would get using the axis of symmetry. That point there that's left over in blue. And therefore, I'd now be able to, go to green, I'd now be able to smooth in that right-hand side with that green marker just as easily as I'd smooth that left-hand side in. And I'd get a pretty nice U shape. Okay, that was 12 minutes to do that first problem. Now let's see if we go to the next page if it makes any sense to us. So as we move to the next page, here's some examples of some parabolas drawn, and I want you to be able to identify the parts. Okay. We're not calculating them here, we're visually looking at them and pointing them out in the picture. So let's take a look. It's asking us to find the x-intercept. Now I asked it twice. It's the same. I'm sorry. The y-intercept is really question 1 and 3, so we'd only need to answer it once. So remember what the y-intercept is: 0, c. Well, wait a minute. They didn't give us the formula, so I have to find it graphically. So remember what that means. It's where the parabola crosses the y. And that's right over there in red at -3. And the name of that point is 0, -3. Don't put it flip-flop and give me -3, 0. 0, -3. Identify the x-intercepts, number 2. Now, that means, can you find them? And can you name them properly? There they are there. That one to the right is 3, 0. That one to the left is 1, 0. Those are the x-intercepts. What is the vertex? The vertex is the turning point. So unlike the last question on the page where we calculated it, we're just going to try to identify it. So we're going to look at our xy axis and see how many units to the left and to the right. So it looks like I have to go over 2 units on the x and 1 on the y. So the vertex is 2, 1. Any questions there? All right. Also, notice that that vertex, if they asked you, is a maximum. Okay, so the point is 2, 1. We'll find the axis of symmetry. Well, it's not in the picture, but remember that the axis of symmetry has the same x-coordinate as the vertex because the vertex passes through that axis of symmetry. I'll make the axis of symmetry yellow. So here it is right here. It's our mirror. And You can tell by looking at where it crosses. It crosses there at 2. So therefore the axis is x equals 2, just like it was in the vertex point, the x-coordinate of the vertex point. Okay. We can also see for question number 6 that the parabola is facing downward. What does that mean? It means even though they didn't tell us the equation, we know that the a had to be negative. Even though we're not looking at an equation, that's what would have had to happen. And that vertex would be a maximum of the function. Okay, let's look at the next one. Again, no equation, so we just want to be able to find the points and know what x-intercepts are and turning points are and y-intercepts. So the first question says, can you tell me where the y-intercept is? 0, comma what? Well, let's use red. It's right there. And if we count the notches, this one is -1 and that one's at -2. So therefore, the y-intercept is at 0, -2. Right there. It says, what's the name of the vertex or the turning point? Okay, well that vertex is right over here. Let's put that one in red. And look at the coordinates. What's the x and what's the y to get there? So it looks like we have to go 1 to the right and down 3. The next question says, where's the axis of symmetry? Well, remember from the previous question that the x-coordinate of the vertex is also the name of the axis of symmetry. So the x-coordinate of the vertex is also the axis of symmetry. So here it is in yellow again, like the last picture. And we can see that it's passing right through and hitting the x at the number 1. So the axis of symmetry is x equals 1. And it said draw it in there, and I just did that. Okay. A little more coming up on the next page. Well, for problem number 3, you notice that they did give you the equation. And by the way, it happens to be the same picture as the first page that we did together, where we had all the formulas given to us. Don't look back. Let's see if we can find some things here. So they want to know those x-intercepts. X-intercepts where the curve, the U-shaped parabola, hits the x-axis. That's at 3, 0. And back here, it's at -1, 0. Okay. So therefore, we can write that in over here. The x-intercepts are 3, 0, -1, 0. And we're not worried about, can we see them in the equation? Don't worry about that. Where's the y-intercept? Well, notice the y-intercept is at 0, -3. Do you see that in the equation? Oh yeah, we want to be able to see that in the equation because that 0, -3, right, is the 0, c. And so I always, when I do have to graph one of these by hand, again, I always want to see that the a value, in this case, is 1, the b is -2, and there's our c, and we can look in the equation and get, yes, it's 0, c. That's how come we know. We can look at it in the equation and see that it's 0, -3. Questions there? Well, you'll have to email me if you have them. Hopefully you don't feel too bad with some of this. One more review question before we have to kind of look at graphing and finding all the stuff ourselves by hand. Again, these are all done for us, so we're just trying to find the information based on the picture. So you notice, once again, they did give us the equation. Okay? And just for the heck of it, for practice, the A, B, and C are important to recognize. The A is there at -1. The B is -2. And the C is +8. Okay. And again, we want to know that if we had to calculate it. Well, they're asking us to look at the picture and name the vertex. Well, that vertex is up there at -1, 9. If I had to calculate it, remember, I'd have to do that -b over 2a and then substitute it to get the y. Okay? So we didn't have to do that because they drew the picture for us. The y-intercept, where is it? We'll go red. Here it is over there. 0, -8. Oh, yes. We also knew that it was 0, +8, sorry. And we also knew it was 0, +8 because it's the 0, c, isn't it? 0, c. The axis of symmetry passes through the vertex. What's the name of that equation? Well, it's passing through the vertex. We'll go with our yellow on our axis of symmetry. Here's the vertex up here at the top. And that axis of symmetry is that imaginary line that passes through. And we can look where it hits. It hits the axis at -1. The equation is -1. X equals -1. Also, remember as we said before, it's also the same as the x coordinate of the vertex. And we can see that the parabola is down. Question number 4 is saying, what value in the equation tells you its direction? Oh, we can see that a equals -1. Okay? And here was that equation, right? Y equals -1x squared minus 2x plus 8. And because that a is negative, therefore, we know it goes downward. Okay. So those were finding the values based on the picture already drawn. Now let's see in the next question if we could draw it ourselves. Okay, well, I'm in the process of creating this video that you're looking at, so I may say that we may not get to the end because I don't want to go too many minutes. I may have to include the rest of this problem. We'll see how far we get. I may have to include the rest of it on video number 2. So here's our equation. F of x equals x squared minus 6x plus 5. It's going to ask us to find all those same things that they gave us before. We have to calculate them. So that means our first move is tell me what A is, tell me what B is, and tell me what C is because we're going to need those. A is the coefficient in front of that x, 1. B is -6, and C is 5. So if we have those values, we know a couple things. Okay? First of all, even though they didn't ask us, we know that this parabola is going to be shooting upwards because the A is a +1. Keep that in mind for later. Wants the y-intercept. The y-intercept is 0, c. You see why we did all that work first and found out what the A, B, and the C was? 0, 5. Provide the equation for the axis of symmetry. That's the -b over 2a. So let's see what we get. Keep in mind the negative is in front of the equation. And now I'm going to take b, change color here. I'm going to take the b, which is -6, and put it in there. And the a is 1. So I substituted the b and the a. Now we just watch our numbers and watch our signs. That's a +2. 6 over 2 is +3. So the axis of symmetry is an equation, x equals 3. And while we're at it, let's do the vertex. Remember that vertex is that same -b over 2a that we just calculated right above? And then all we have to do is substitute it into the formula to get the y coordinate. So we already know that this -b over 2a was already calculated to be 3. So our hard part now is to substitute that 3 into the equation. Well, it's not hard, but this is the part where we need our calculator. Okay, so when we substitute, here's our equation, x squared minus 6x plus 5. And when I substitute, we'll make those substitutions there in red so that you can see them. Okay, we're going to put the 3 in there. And we're going to put the 3 in there for the other x. And we're going to leave everything else alone. Okay. So the blue is the original equation, and there's my 3 that I'm going to probably make red over here too. So what do we get there? That gives us a 9 minus 18 plus 5. And that's where we have to pull our calculator out. That gives us a negative 4. And guess where that goes? Right over here. So the vertex is 3, negative 4. So let me see, I'll use green. Let's circle the important things that we found. We found the y-intercept was 0, 5. We found the axis of symmetry was x equals 3. And we found that the vertex is 3, negative 4. Let's graph all these things. Let's put these items that we just calculated into the picture and see how it's going to look. So I'm going to start at the top. Y-intercept, 0, 5. That's going to be right here. Looking at the graph. 0, 5 goes in right there. It says, tell me what the axis of symmetry is. X equals 3. Okay, so let's see if we can, we'll do that in yellow. Here's 1, 2, 3. So I'm going to make that axis of symmetry right down there. Okay. And I'm going to label it x equals 3. I don't know if it's going to ask you to label it on the test, but we always want to label if we can. Now, the important point is let's get that vertex. And that vertex is 3, negative 4. So I'm going to come over here, 3, and go down 4. 1, 2, 3, 4. And here's my vertex, 3, negative 4. Okay. So, we can see that it is going upward. And that somewhere in this picture, we're going to have a U shape. Okay. Except I probably want to get another point. Notice this question D says, write the axis of symmetry down and use it to find an additional point. So remember what I said before, that we could work off of the y-intercept and see how many notches away it is from the mirror axis of symmetry, 3. So I'm going to go 3 in the other direction, 1, 2, 3. And there's another point that I can add into the mix. And so now when it's time for me to graph this thing, I can kind of visualize the U the way it's going to be. And that's what we wanted to attempt to do. All right. Okay, our last 2 comments. We'll finish this question up and then we'll move to a second video. They'll always ask you, of course, what we were asked on test number 1. What's the domain? What's the range? So the domain is all values of x. This is always the same on a parabola. It runs from negative infinity, all the numbers over here all the way on the left side. I'm putting the negative infinity there, all the way to the numbers on the right side. Now we're only looking at a piece of that parabola, but we can pick whatever x's we want on that x-axis with no limitation. We can go all the way to the left, negative infinity, all the way to the right, positive infinity. Okay. However, remember, so the domain tells you the x's, how far to the left and how far to the right, what kind of numbers can I use, no limitation. But on the range, we got to look at our picture. So our range, what happened to my blue? Oh well, we'll go with black. Oh no, we'll go with blue. Look where the range is. How low does it go? Well, it goes make it green. It goes as low as -4, but the picture, that parabola, that U shape goes forever and ever and ever and ever upward. So it goes as high as positive infinity on the y. Remember, the range is the y. How high up and how low, how far down do the values go? So it goes no less than -4. So -4, and there's a solid dot at -4, you remember. The solid dot translates to be a squared off bracket, means it includes the -4, and it goes all the way up to positive infinity, and we use an open parenthesis for that. And there's our range. Okay? And the range is always taken off of the vertex. Look at that vertex, look at that y on that vertex. And that tells you where you're starting or ending, because keep in mind, it also could go the other way if it was heading downward. All right? And we'll stop there and go to the next video.